This is the story of an epic adventure. A story of cosmic curiosity, courage and perseverance. The story of how Europe went south to explore the stars. Welcome to ESO, the European Southern Observatory. 50 years old, but more vital than ever. ESO is Europe's portal to the stars. Here, astronomers from 15 countries join forces to unravel the secrets of the universe. How? By building the largest telescopes on Earth, designing sensitive cameras and instruments, scrutinizing the heavens.
Cooperation has always been the basis of ESO's success. 50 years ago, the European Southern Observatory started out with 5 founding member states: Belgium, France, Germany, the Netherlands and Sweden. Soon, other European countries followed: Denmark in 1967, Italy and Switzerland in 1982, Portugal in 2001 and the United Kingdom in 2002. Over the past decade, Finland, Spain, the Czech Republic and Austria also joined Europe's largest astronomy organization. Most recently, Brazil became ESO's 15th member state and the first non-European country to join. From remote mountaintops in Chile, European astronomers are reaching for the stars. But why Chile? What made the astronomers go south?
The European Southern Observatory has its headquarters in Garching, Germany. But from Europe, only part of the sky can be seen. To fill in the gaps, you have to travel south.
ESO's first telescopes on La Silla were a mixed bunch. They ranged from small national instruments to large astrographs and wide-field cameras. The 2.2-meter telescope, now almost 30 years old, is still producing some of the most dramatic views of the cosmos. At the highest point of Cerro La Silla lies the biggest achievement of ESO's early years, the 3.6-meter telescope. Aged 35, it now leads a second life as a planet hunter. Also, Swedish astronomers built a shiny dish 15 meters across to study microwaves from cool cosmic clouds. Together, these telescopes have helped to unveil the universe in which we live. Astronomers were clearly in need of more powerful telescopes, and ESO provided them with revolutionary new tools.
The VLT is ESO's flagship facility, 4 identical telescopes joining forces on top of Cerro Paranal in the north of Chile. Built in the late 1990s, they provided astronomers with the best available technologies. In the middle of the Atacama Desert, ESO created an astronomer's paradise. Scientists stay in La Residencia, a guest house partly buried under the dirt and rubble of one of the driest places on the planet. But inside are lush palm trees, a swimming pool, and delicious Chilean sweets. Of course, the unique selling point of the Very Large Telescope is not its swimming pool, but its unequalled view of the universe.
And this is the state of the art. The mirrors of the Very Large Telescope, the VLT, are 8.2 meters across, but only 20 centimeters thick. And here's the magic. A computer-controlled support system ensures that the mirror keeps its desired shape at all times, to nanometer precision. Without thin mirrors and active optics, the VLT wouldn't be possible. But there's more. Stars appear blurry, even when observed with the best and largest telescopes. The reason? The Earth's atmosphere distorts the images.
Enter the second magic trick, adaptive optics. On Paranal, laser beams shoot out into the night sky to create artificial stars. Sensors use these stars to measure the atmospheric distortions, and hundreds of times per second, the image is corrected by computer-controlled deformable mirrors.
And the end effect? As if the turbulent atmosphere were completely removed. Just look at the difference.
The Milky Way is a giant spiral galaxy, and at its core, 27,000 light-years away, lies a mystery that ESO's Very Large Telescope helped to unravel. Massive dust clouds block our view of the Milky Way's core, but sensitive infrared cameras can peer through the dust and uncover what lies behind. Assisted by adaptive optics, they reveal dozens of red giant stars. And over the years, these stars are seen to move. They orbit an invisible object at the very center of the Milky Way. Judging from the stellar motions, the invisible object must be extremely massive. A monstrous black hole weighing in at 4.3 million times the mass of our Sun. Astronomers have even observed energetic flares from gas clouds falling into the black hole, all exposed by the sheer power of adaptive optics.
So thin mirrors and active optics make it possible to build giant telescopes. And the adaptive optics take care of the atmospheric turbulence, providing us with extremely sharp images. But we're not done yet with our magic tricks. There's a third one, and it's called interferometry.
The VLT consists of 4 telescopes. Together, they can act as a virtual telescope measuring 130 meters across. Light collected by the individual telescopes is channeled through tunnels and brought together in an underground laboratory. Here, the light waves are combined using laser metrology and intricate delay lines. The net result is the light-gathering power of 4 8.2-meter mirrors and the eagle-eyed vision of an imaginary telescope as large as 50 tennis courts. 4 auxiliary telescopes give the network more flexibility. They may appear tiny next to the 4 giants, Yet they sport mirrors 1.8 meters across. The Very Large Telescope Interferometer reveals 50 times more detail than the Hubble telescope. For instance, it gave us a close-up of a vampire double star. One star is stealing material from its companion. Irregular puffs of stardust have been detected around Betelgeuse, a stellar giant about to go supernova. And in dusty disks surrounding newborn stars, astronomers have found the raw material of future Earth-like worlds. The Very Large Telescope is mankind's sharpest eye on the sky. But astronomers have other means to expand their horizons and broaden their views. At the European Southern Observatory, they have learned to see the universe in a completely different kind of light. San Pedro de Atacama. Tucked amidst breathtaking scenery and natural wonders,
Not far from San Pedro, ESO's first dream machine is taking shape. It's called ALMA, the Atacama Large Millimeter Submillimeter Array. ALMA is a joint project of Europe, North America and East Asia. It operates like a giant zoom lens. Close together, the 66 antennas provide a wide-angle view, but spread apart, they reveal much finer detail over a smaller area of sky. At submillimeter wavelengths, ALMA sees the universe in a different light. But what will it reveal?
the birth of the very first galaxies in the universe in the wake of the Big Bang. Cold and dusty clouds of molecular gas, the stellar nurseries where new suns and planets are born. And the chemistry of the cosmos. ALMA will track down organic molecules, the building blocks of life.
At 5,000 meters above sea level, the array provides an unprecedented view of the microwave universe. While ALMA is nearly completed, ESO's next dream machine is still a few years away. See that mountain over there? That's Cerro Amazonas. Not far from Paranal, it will be home to the largest telescope in the history of mankind. Meet the European Extremely Large Telescope, the world's biggest eye on the sky.
Sporting a mirror almost 40 meters across, the EELT simply dwarfs every telescope that preceded it. Almost 800 computer-controlled mirror segments. Complex optics to provide the sharpest possible images. The EELT is an exercise in superlatives. But the real wonder, of course, is in the universe out there. The EELT will reveal planets orbiting other stars. Its spectrographs will sniff the atmosphere of these alien worlds, looking for biosignatures. Further away, the EELT will study individual stars in other galaxies. It's like meeting the inhabitants of neighboring cities for the first time. Working as a cosmic time machine, the giant telescope lets us look back billions of years to learn how everything began.
Astronomy is big science, and it's a science of big mysteries. Is there life beyond Earth? What's the origin of the universe? ESO's new monster telescope will help in our quest to understand. We're not there yet, but it won't take long. So what's next? Well, no one knows, but ESO is ready for the adventure.